think it's pretty incredible that we've come all the way across the world and come to see the actual rifle made in Finland for our Canadian Rangers.
Yeah, it's an amazing rifle, and it's a great place here in Finland that we're able to see where it was designed and developed for the Canadian Rangers.
Absolutely. The Sako factory, we just sat through a really neat, interesting presentation on the history. I had no idea they were almost 100 years into rifle production.
Yeah, absolutely. It's been a key component in Finland's independence, and it's where it is today.
Absolutely. Well, I'm thrilled to be here. I'm thrilled to be able to see sort of what's behind the scenes of building these rifles. But I mean, this is a good example of Sako and Tikka engineering in terms of being able to build things and adapt things that are mostly all about usefulness.
Absolutely. I mean, first and foremost, the gun's got to work. It's got to be accurate. It's got to be able to put up with the demands of the hunters, and especially in remote and harsh conditions that you know, as hunters, we love to go to.
Absolutely.
And our rangers use these rifles for sustenance. You know, it's something that's so important to them. They're in remote areas. They need it to survive. And certainly, you know, we're happy to be able to design that rifle that will help them do that.
Well, I'm anxious to see how it's designed. So let's go check that out.
Right on, this way.
Right on.
Welcome to the bolt machining. This is the bolt manufacturing cell. We produce Sako 85 bolts into our rifles over here. The raw material for the bolt starts from the forging, and then we are milling the operations in the 5-axis Kitamura. And we are turning first the handles and then drilling the firing pinholes. And within this machine we put it into the clampings, and then we are milling the locking logs, which we have 3 in this Sako 85.
Right. That's a lot of machining all happening. When you look at this piece to that, when you consider, I mean, we're talking, that's been hollowed out, and all the different intricacies, that's quite a process.
So the key thing here is to see how it starts as a one-piece forge, and then turns into the one-piece bolt that Sako's been so known for.
Absolutely.
Yes.
I imagine the strength of your bolt comes from the solid raw materials.
Yes, it is the forging, and the structure of the forging is very, very robust.
Sure.
We have measuring equipment in the cell already. Then we have also the metronomic laboratory, and it gives feedback for our statistical process control.
Okay. And then the end result, I mean, the Sako 85s are known for such a silky, smooth action. That's got to be all a part of that quality control process and that preciseness you talked about.
True, yes.
Wow, excellent. What's next?
Let's go to the next step, the milling operations of the receivers.
Okay.
This is the receiver milling cell. We have 2 machines over here. With both of them have one spindle, and the robot in the middle as a manipulator. It gives the raw material in my right hand over here to the machine, and the machine with the 2 clampings is milling the receiver like this within my left hand.
Wow.
So this is complete receiver after the milling operation.
So with one robot, multiple machines within the area, it's able to take this and turn it into that.
Yes, completely.
So you see it going in and out, like, so I guess that's all the different stages, right? And then pulls it back out. Looks like it cleans it or blows it off or something?
Yeah, it is cleaning the chips away before it comes to the locker.
Okay, that's a lot of machining to happen, because basically that's essentially finished. I mean, there can't be much more to be done to that.
Only finishing operations, which is deburring, and then hard finishing after the heat treatment, chemical tumbling, so on.
Fascinating. To think that that goes in and that comes out. That's pretty cool. Wow. Excellent. Okay, what's next?
Next we are going to the quality room. Now we are coming in to the most important place. within the quality. So this is the quality laboratory, and all the traceability of our measures is taken care over here. Also the calibration of our production done here, and they are making random tests to our products and giving the feedback to the production.
So like those little red things I see.
This is the Rubin ball, which is exact from the contour of the roundness.
Oh, okay.
It is red Rubin. You cannot have it.
And the whole purpose is it's measuring all these...
It is measuring the dimensions and giving the data into the computer, and we can get the statistical process control.
So even though the machines are the CNC machines, sophisticated machines, we still don't trust them by themselves. We still use this to make sure that they're working the way we need them to work. So we ensure that there's consistency throughout all of them, and they're meeting the standards that Sako requires.
And also we all know that when you are discussing about the statistical process control, we are checking that the certain diameters or the measuring lengths are between the tolerances. And if this machine is creating data that is going in the upper limit or the lower limit, we can get an alarm and adjust the machinery accordingly.
Gotcha. Wow, that's incredible. So basically this is doing bolts right now, essentially.
At the moment it is doing bolts, and we can also have the feedback from the receivers, and if we can imagine how many data points are there in the receiver, we have at least 200 different measurement points.
Incredible.
And if you think about the authorities, they are very strict about the quality, and we can guarantee for the authors that our rifle is safe and accurate.
And is this step something that's mandated? Is this required by government?
This is not required by the government. This is required by the customers.
Good for you.
Good point. Good point.
Very good. Wow.
Behind us is the hammering cell. We are hammering the barrel blanks into the blanks that have rifling inside. And you can see the difference in the length before hammering and after the hammering.
That's incredible. So basically you're saying there's 4 pieces of metal that are basically hammering against working against each other, hammering this thing down, which ultimately stretches this raw material. I mean, you almost lengthened it out by almost a third, and it stretches all that. There's no material lost. There's no drilling. There's no shaving. No sanding. It just stretches it out. Only hammering. Amazing.
Well, some would say there's a stress problem, but you know through the heating process, it relieves all that stress that's built up.
Yes, we are releasing the stress after the hammering in the furnace, and we give it approximately 600 Celsius, some hours.
Wow.
How do you keep the barrel true? Because that's already drilled, right? How do you keep the barrel true, the caliber true when you're hammering?
There is inside, there is a tool called mandrel, and inside the mandrel there is a shape of the rifling, and it is copying the rifling.
So it's running along with the hammer, and the hammer's hammering against it.
Yes.
So the rifling's not cut, the rifling's an impression that's put on the inside. So it's hammered in.
Yes.
And this is why the Sako barrels, you don't have to go through that process of breaking in the barrel. So from the day you take it out of the box, you can start shooting, it's accurate, reliable, and it extends the barrel life.
Sure,
so from a hunting and shooting perspective, you don't have that temperamental process.
Well, and if you're not cutting it or drilling it, you're also not getting all the burrs, which is part of that break-in process, but you're not getting any of that.
Right.
There are no deburrs.
There's no deburrs needed at all. So once it's hammered, the rifling is done.
Yes.
So we're only dealing with the lathe and cleaning up
outside shape and the cartridge chamber.
And the chamber.
Yes.
Isn't that amazing?
That's got to be quite a process. I mean, I can hear it's quite a process. That's loud in there. but that must be quite a amazing amount of pressure to be able to do that.
That's true. We are now so-called robot cell. We are doing here the barrel operations after the forging.
Okay.
After the stress relief, we are putting it into the cell, turning outside diameter of the blank, so the shape of the barrel is coming here, outside shape.
So we've done the cold hammer forge.
Yes.
Now the barrel in this raw state comes to this point, and
True.
now the outer contours are cut out and laid down.
Yeah.
Now you're basically making it look like a barrel.
True.
That's essentially what this is
what
doing,
we're
right?
doing,
Yeah,
right?
the outside shape of the barrel, and then after that, in this cell over here, we are making the cartridge chamber
Ah, okay.
with the reaming operation.
Okay.
And we have here 3 turning machines, 2 robots, and 2 spindles in the cartridge chamber, and 1 operator is using all of
All
those
of it, wow.
in the 1 shift, and we have 3 shifts over here at the moment.
Wow.
Enough capacity at the moment.
Yeah. That's fascinating.
Every barrel is checked, and our operator is doing the check. He's checking the rifling, the cartridge chamber, and the mouth, so the crown.
And what's he checking for, though?
He's looking for the defects, if there is any. Against the light, you can see that if there is some problems with the chamber, let's say that the cutting tool has broken, there is a ring
okay.
or something like that.
So interesting that this is another one of those steps that's done by the human eye rather than by some kind of electronics or robotics.
Yeah. This is the best way to guarantee the accuracy, because after this point, these barrels are going to the assembly and into the shooting range.
Gotcha.
So they are ready to play now.
Wow.
After that.
Another case in point where modern, advanced, state-of-the-art machinery takes it so far, but we still need that human touch on
Absolutely.
the other side to
Yeah.
make sure that there's a balance,
Yeah.
you know,
Yes.
within the product.
And of course, you have to have special skills. Your eye must be very precise to see the defects.
Sure.
This is assembly station of Sako 85.
So this is kind of where all the magic happens. It all comes together right here.
Yeah, we have collected the trolleys with the receiver, barrel, and the bolt,
Ah, okay.
assembled bolt. And the gunsmith is making the assembly from the beginning till the end before the shooting range.
So you're saying one gunsmith is taking the whole gun from components to finished gun, all in one step?
Yes. And he is signing also that I have made this rifle and with this identity, and also it gives certainty for the feedback.
So,
when
by putting his
something-
name on it, he's basically, you know, it's a sense of pride.
Yeah,
for him.
absolutely.
This is his
Ownership.
name's on it. So I mean, of course, it's all Sako,
Yeah.
but I mean, his name's on it. He assembled the gun, so there's the pride of workmanship that,
Yes,
that
yes.
he's completed this.
No, I just watched him test the trigger too there. So what's he doing? Like, is he testing weight? Is he testing?
He's testing the trigger weight, how much power you have to use
Right.
when the trigger is
Wow.
tricked, launched.
Yeah.
And in each step within the machining cells and in the assembly cells, we have several measuring points for the quality.
So this is the stuff that the average consumer never gets to see how it all comes together. But as a consumer, for a lot of years, I've always been able to feel the quality. This is exactly why. You can see the pride of workmanship in your employees, and that shows up in the end product.
As we've seen, we've got the machines, state-of-the-art machines, the quality control area. We've done all the process.
Yeah.
So he's still another step of quality control. So
Yeah.
one is not just the personal assembly. He's still doing the checks and balances here to make sure that the consumer, the final product, is what it needs to be.
There's still so much hand-on gun contact where a guy's eye and expertise is doing it. I think that's fantastic.
Absolutely. You know, it's not machines that are out there hunting, it's people.
That's right.
And so
That's
it's
right.
people assembling the guns.
We are now in the high pressure room. This is for the safety of the operator. We are loading the cartridges with more pressure than normal. It is approximately 30% more pressure
Wow.
than in normal cartridge.
So this is to make sure all those guys who like to reload hot,
Yeah.
this is to make sure that they don't blow themselves up.
Yes, and after that we are measuring with the gauges the cartridge chamber that the diameter and the length is okay.
So every gun that Sako produces is put through this chamber. So 2 cartridges up
Yes.
to 30% over the maximum pressure.
Yes, every
is
rifle.
fired
Yes.
in the gun. So every 100% of the guns it's done to, and then with the gauges, it's all checked to make sure there's no problem with headspace or anything
Yes.
else that's and then so the gun proven safe.
Yes.
So they know it could withstand high pressures, and so as a consumer, as a hunter, you don't have to worry about the gun.
It is ready to play when you buy it. And we are checking every case
Yes,
of
I
the
noticed
cartridge also to see if there is any marks on the case.
Right. Thank you. This looks like a fun room.
This is Sako shooting range, and we are testing every rifle accuracy in this shooting range. We have 100-meter range over here, shot by the gunsmith, and we are shooting 1 magazine every time. Tikka is 3 shots, and Sako 85 makes 5 rounds.
Okay.
Every gun is shot.
True.
100% of guns are shot, and the accuracy is logged and documented for each gun.
We guarantee 1 minute of angle within the 100 meters range within every rifle.
So when you say 1 minute of angle, we're talking basically a 1-inch groove
Yeah.
at
True.
100 meters.
100 meters. And that's probably a lot better than a lot of our hunters
Yeah.
actually shoot.
Yeah, we should all strive to be there, but certainly
Yeah.
it takes some
Well,
effort.
and you see all kinds of marketing things, right? That
Yeah.
guys will make statements about products.
Yeah.
You literally can say, we're not just manufacturing a gun to do this, you're actually proving that it does it.
Yeah, we guarantee it.
You guarantee it.
And Paul, you know, the amazing thing here is there's an actual shooter.
Right, not a machine.
It's not a machine, it's not a vice, it's not a system. It's a guy who's behind the gun,
Yep.
who's looking at it and pulling the trigger on
Absolutely.
it and being able to perform it. So
And he is professional, shooting very many rifles per day.
There's probably no one that pulls the trigger as much as him.
Yes.
Wow.
This is the final step in our rifle production. We are packing the rifle individually into the pack, and then also we put into the computer the identity number of each rifle, so that the authorities know that now we have packed the rifle.
Ah, okay.
And here is also last visual check, cleaning, and and also the manuals in, and also the guarantee paper
Right.
for
Right.
the accuracy. It is ready to go to the warehouse and to the customer.
Excellent. Well, thank you. We've had a truly educational experience, and it's been a lot of fun being able to see the work that goes in. You know, as a shooter for a lot of years of these great firearms, it's nice now to see the investment that you guys put into it. Because I mean, you know, when we invest into it financially, we see that we're getting great quality out of it. So thank you very much.
It is our pleasure. Thank you for visiting us.
Well, we hope to do it again.
See you soon.
Thank you.